Hello everyone, welcome to TE Connectivity LUMAWISE ALR Photocell presentation. My name is Vu Lack. I am a field application engineer with TE Connectivity. I am joined by Jonathan Catchpole, TE's system architect, during this presentation. I would like to start with, what is a photocell and what does it do? It is simply a main switch with an ambient light sensor. In many regions, like the US and UK, streetlights are permanently powered. Therefore, each luminaire needs a device to turn it on and off. A photocell provides the on and off function. The bottom left is a typical architecture of a luminaire with a photocell. The photocell sits between the incoming power and the LED driver. It acts as a switch to allow power to the LED driver. The bottom right picture is a simple photocell circuit. It consists of a power supply, an ambient light sensor, and a relay. The relay will open or close when the ambient light level meet the defined spec of the photocell to power the LED driver. There are two types of TE LUMAWISE ALR Photocell. A 3-pin locking style, which is ANSI C136.10 compliant. The other type is hardwire products. There are two technology platforms in our LUMAWISE ALR Photocell. The thermal type consists of a cadmium sulfide light sensor and a bimetallic snap action relay. The electronic type consists of a silicon phototransistor, which is IR filter or unfiltered, a 30 amp rated open frame electromagnetic relay, surge protection using an MOV, has a dust tight and rain tight cover, which is high impact resistant and is UV stabilized polypropylene. It has a high temperature PBT base, therefore providing strong performance in high ambient environment. In the next few slides, I will discuss TE's preferred product within the LUMAWISE ALR offering. The first preferred product is our AA series button type photocell. It is designed for internal mounting. It has a 3/4 inch long threaded sensor protrusion. It has a 30 to 45 second time delay. It is UL and CSA listed. It also meets the ANSI C136.10 standard. Next preferred product is our 7000 series. It is designed for incandescent light sources. It has an 8-year rated life, an enhanced surge protection circuit. It also utilizes an open frame relay, and it also has a long life housing. Some key specs are listed to the right for your review. Another preferred product is our 8000 series. It is designed for LED luminaires. It has a 20-year rated life, uses long life caps, an enhanced surge protection, and it uses a large contact open frame relay, and also it is housed in a long life housing. One key difference of the 8000 series is that it is available in fail on or fail off mode, unlike the 7000 series, which is only available in fail on mode. Now, Jonathan Catchpole will discuss why the 8000 series is best for LED luminaires.
Thank you, Vu, for that detailed overview of our ALR product portfolio. As Vu said, I'm Jonathan Catchpole, a system architect here at TE Connectivity, and today I'm going to take you through why you should select our 8000 series for an LED luminaire. So let me start by sharing the presentation. On this slide, I'm showing two very simplified circuit diagrams. The first is for an incandescent light source. which are the typical high pressure sodium lights we are all used to seeing. These are a resistive load. So when the photocell is switched on, the voltage and current across the load rises at the same rate. The second diagram is for an LED light source, which is a capacitive load. This time, the AC mains is used to power a driver. The driver takes the AC waveform and uses a bridge rectifier and a DC coupling capacitor to create a constant current output to power the LED light source. But in this case, when the power is first switched on, the capacitor will look like a dead short and will try and pull as much current from the source as possible, causing an inrush. You can see on the graph that as the capacitor charges to the line voltage, the current flow reduces. It is this inrush current that can cause relay contacts to weld, preventing the light from being switched off. Our 8000 series has been designed to prevent this from happening. When the contacts are closed, there will be a point of high resistance. During the inrush of current, this high resistance could cause the contacts to melt and weld shut when the metal solidifies. The 8000 series utilizes a relay with larger contacts. This increases the amount of contact points and in turn reduces the contact resistance, which helps prevent the localized heating and melting of the contacts, which could cause welding. I now want to play you a high-speed video of a relay opening. You can see the arc that is generated and the duration before it extinguishes. Although it is very unlikely that the contacts will weld when the relay opens, the video gives you an idea of the energy involved in switching mains voltage. When closing, the same arc will be created, albeit for a much shorter duration. I hope you found this informative, and if you have any technical or commercial questions, please contact us on the email addresses shown.